Okay, here we are on page 3 of the review, and um, uh, you should have your half page of formulas. If you want to copy this down, hit pause. Okay, so here's the question. We did this one in the whiteboard task the other day, and so you've got this angle here. They've told you it's obtuse. You've got this is 5, and that's BC, and you know the area is 20 centimeters squared. So when I look at the formula here, the only one that has triangles and area is this guy right here. So I'm going to write the area formula down. So we know the area is 1/2 AB sine C. So when we're using this formula, you need to remember this angle is the included angle between the two sides we're working with. So um, here is this guy right here, and you're trying to find the included angle, which is this angle right there. Okay. So um, and you know the area, they've told you this area is 20 centimeters squared. So I'm just going to fill in the details that I know. So now I've got 20 centimeters is our area, and I've got 1/2, and A is 5, and B is 13.6, and then sine C, and we're trying to find angle C. Okay, so I've got my calculator here, and I'm going to hit clear. So I'm going to do 5 times 1/2 times 13.6, and I'm going to get 34. So now I have 20 equals 34 sine C. Okay. Now to solve for C, I need to divide both sides by 34. Okay, and that's going to make this and this cancels out. So now I have sine C equals 20 over 34. So let's do that. 20 divided by 34, and I'm going to get this decimal. Let's just write over here. Sine C equals 0.5883, right? So now I need to do the inverse sine, sine a little -1, 0.58823. I'm not going to retype this decimal. I'm just going to hit, second sine to get my sine with a little -1. And then I'm going to hit second and this little negative button down here, this one right here that I'm pointing at. And now it's going to say answer, because it's going to do the inverse sine of this previous answer, and now it's going to tell me my angle is 36.03 degrees. So I'm going to say angle C equals 36.0 degrees. Now, that's not the answer, because they told you that it is obtuse. So this is a bigger angle. So what do we have to do? So you need to remember, in order to find the obtuse angle, I have to do, because we've got an ambiguous triangle. So you're going to want to watch the video on ambiguous triangles if you don't remember that. So if you got an ambiguous triangle, you do 180 minus 36 degrees, and then you're going to get 144 degrees. So angle C equals 144 degrees. Okay. And remember, this is, as I said earlier, this is our included angle. You may want to label that on your paper. Okay, so now that I use, if you don't use this correct angle, it's going to mess up your calculation here. So now you want to find the length of AB. So I'm going to put a lowercase c here. Okay, so to find the length of AB, we've got side, angle, side, right? Side, angle, side. We have the included angle between two sides we know. So if I've got side, angle, side, I can look at my formula sheet, and side, angle, side, I'm going to be using the cosine rule. And I'm going to be using this first one because we're trying to find the length of the side. We're not going to use the second one because that's trying to find an angle. We know the angle is 144. Okay, so we're going to try to find this side, the lowercase c. So I'm going to rewrite this formula here. C squared equals a squared plus b squared minus 2ab cosine c. I'm rewriting that formula down. And so now let's write in the information. We've got 5 squared plus 13.6 squared minus 2 times 5 times 13.6 and cosine 144. Okay, and I'm going to type that into my computer, and then I'm going to get 25 plus 184.96 minus 136 cosine 144. Now, be very careful, because if I hit cosine of 144, we're going to get a negative number. If I do cosine 144, we get negative 0.809, whatever. So, so if I have 136 times so I have 136 times the previous answer. Let's turn this off. Maybe that might help. Okay, so the previous answer. Whoa, we can't see anything. Okay, that clearly didn't help. 136 times the previous answer, and that gets us negative 110. So here I have 25 plus 184.96 minus negative 110.026. Okay. So clearly that's going to become plus. So then I add all this together and I get 319.98. And remember that's c squared. So I've got to take the square root of that. And then I'm going to get the line AB is equal to, the square root of that is 17.9 centimeters. Okay. Now this next one we did as a whiteboard task, and you got good conversations with your classmates. So whenever you see the word write down, that means that's code word for this is supposed to be easy, don't overthink it. So from here to here, you know, is 85. From here to here, you know, is 85. Think of this as like a wheel. Everywhere to the edge of the wheel from the center is 85 meters. So the distance from here to here, guess what, is 85 meters. Oh, some of you may be saying right now. So that distance is 85 meters. Okay. So now they want you to find the perimeter of the park ABED. So, um, so, so here, A to B to DE, and then back. Okay, so the first thing I need to do is I need to figure out the length of this arch. Okay, so to figure out the length of this arch, I'm going to use my length of an arc equation. Okay, so the length of an arc equation is theta over 360 times 2 pi r. Okay, so we know our radius is 85, and we know our angle is 70. So I'm going to replace that information. So I've got 70 over 360 times 2 times pi times 85. And that is the length, L. Okay. Okay, that's that length from there to there. Okay. So there were some people that were unfamiliar with pi. The pi button's right here, just underneath the clear button. Okay. So it's about 3.14. So let's type this into our calculator. 70 divided by 360 times 2 times pi. I have to hit second button and this button right here, the little caret button, and that's going to give me pi. And then times 85. And then I hit enter, and then I'm going to get 103.84. So this is equal to 103.85. Okay, that is this length here. So the perimeter is going to be equal to, we've got the 85 plus 85 plus this new length of 103.85. So that's this side here, and the 103.85. And we add all those together, and I get 273.85. So if I wanted three significant figures, I can say the perimeter is equal to 274 meters. Okay, that is the length around the circle, or the sector, yeah. Okay, and then finally, it says, what is the area of the shaded region? Okay, so the shaded region is this space right here. Okay, that space right there is the shaded region. Okay, the best example that I've been using in my classroom is, think of this as a piece of pizza. Pizza. And think of this triangle here as the cheese on the pizza. And think of this blue part as the crust. I want to find the area of the crust. So I can figure out the area of the pizza, subtract the area of the cheese, and now we are left with the crust. Okay, so let's write this down just so we can know what we're doing. So the area shaded equals the area of the sector minus the area of the triangle. Okay, so that's what we're going to be shooting for. Okay, so let's do the area of the sector first. So the area of the sector is equal to, so I'm going to use this formula here, area of the sector. Okay, we know the angle here is 70 degrees. We know the radius is 85 squared. So we've got, I'm just going to rewrite the formula. Theta over 360 times pi r squared. Okay, so our angle is 70 degrees. Our radius is 85, so 85 squared. So I plug that into my calculator, and then I get 4,413.5. I believe that's what we got during class. Okay, what are the meters squared? Okay. Now, so that's this whole area of this whole pizza. Now I want to find the area of the triangle, and so I can use this formula, area of the triangle. So it's 1/2 AB sine C. So the A and the B are the sides on either side of the included angle. So this is equal to 1/2 85 times 85 times sine of 70. Okay, I plug this into my calculator, and I get that that is 3,394.6 meters squared. Okay, so now I can do my subtraction, and I can get 4,413.5 minus 3,394.6, and I'm going to get a shaded area of 1,018 meters squared. And that is the shaded area of this shape. And that is the answer for page 3.